This is perimembranous VSD, and you can see this is VSD, and this is parasternal short axis view. This is parasternal short axis view. You see, structure wise, this is right ventricle, this is right ventricle, this is right atrium, this is aorta, this is left atrium. So VSD is very close to tricuspid valve. Then this is called perimembranous. Location wise, you can say 9-10 location. If VSD is very close to pulmonary valve, then this is called doubly committed, or you can say supracrystal outlet VSD or doubly committed VSD. All VSD is below the aortic valve, so all are subaortic in location. That means below the level of aortic valve. But whenever it is close to tricuspid valve, then we call it perimembranous VSD. When it is close to almost touching the pulmonary valve, then we call it supracrystal outlet VSD or doubly committed VSD. So that is the point to know. I will show both type of VSD. In this case, it is close to tricuspid valve. In another case, we will show you that will be close to pulmonary valve. That will be doubly committed VSD. So this is VSD, and this is perimembranous VSD because it is close to tricuspid valve. You can easily see, in this case, you see this tricuspid valve, some part, some extra leaflet, the redundant leaflet is trying to close the VSD also. In case of perimembranous VSD, closure is quite likely because there is an extra portion of tricuspid valve, that is septal leaflet of tricuspid valve, is used in closing of mechanism of perimembranous VSD. So that is why we usually find the perimembranous VSD closes if you follow up to the age of 6 to 8 years. Simply, this is the moving image. This is 4-chamber view of the same case. You can see the left ventricle is slightly prominent compared to, obviously, in normal scenario, if you compare with normal scenario, left ventricle is slightly prominent. So you have to find out some sort of connections like VSD or other out PDA. This is main pulmonary artery. This is short axis view. The structure, this is aortic valve, this is pulmonary valve, this is right pulmonary, this is left pulmonary artery. Again, the same thing. You can see the VSD is very close to tricuspid valve. So this is case of perimembranous VSD. If you find the blood is also coming into right atrium, that is called Gerbeau defect. So Gerbeau defect, that is same blood that is coming out of left ventricle into right ventricle, that is entering to right atrium, that is indirect Gerbeau, or sometimes it directly entering into right atrium, that is direct Gerbeau defect. Direct Gerbeau means from left ventricle to right atrium, direct connection. Indirect Gerbeau means from left ventricle to right ventricle and then into right atrium. That is the same blood. That same blood is coming from left ventricle to right ventricle, and that blood is coming into right atrium. That is indirect Gerbeau defect. But in this case, what you see, you can see most probably this is coming into right ventricle, then is coming to right atrium. So it is indirect Gerbeau. That Gerbeau defect. Again, you can see this is parasternal view, right ventricle inlet view. So whenever you make right ventricle inlet view, the VSD will become more prominent, will be better seen. So whenever you find VSD, if you are just making right ventricle inlet view means towards tricuspid valve. If your image is showing tricuspid valve, then VSD becomes better, more visible, easily visible, clearly visible. That means it is perimembranous VSD. If it just simply disappears, it means this is not that perimembranous VSD. That is the point from this view, this clip.